Hello there everybody! Today we are going to tell you something about the calculator. Yes, that thing that we all needed so desperately during the mathematics test. Yeah, that test.
There are multiple definitions of the word calculator. 1. A person who calculates or computes. 2. A set of tables that facilitates calculations. 3. A small electronic or mechanical device that performs calculations, requiring manual action for each individual operation, also called a calculating machine. And 4. A person who operates such a calculating machine. And in this presentation we're obviously going to talk about number 3. There are different kinds of calculators. The two main types are the mechanical and electronic calculator, which can differ from pocket calculators all the way to the full-fledged graphical calculators we use almost every day.
In the very beginning there was the abacus, a sort of hand-operated mechanical calculator using beads and rods, first used by Sumerians and Egyptians around 2000 before Christ. For those who had never had the pleasure to use one of these, the idea is quite simple. The beads on the first or top rod represents single-digit numbers, so 1 through 9. The beads on the second rod represent the tens, and so on and so on. With 8 rows of metal rods you could count up to 100 million, if you were patient enough, of course. 3600 years later, at the beginning of the 17th century, Edward Gunter, William Oughtred and others invented the slide rule. It allowed people to do rapid multiplications and divisions and even very advanced and difficult equations like square roots. Men continued to use the slide rule as an important tool in schools up to 1980, even though mechanical and electronic calculators were well established at that time.
The very first mechanical calculator was made by Wilhelm Schinkard. In 1623, he made a machine capable of adding and subtracting numbers up to 6 digits long. But nobody cared, so his invention was lost. 20 years later, Mr. Pascal reinvented the calculator with the Pascal line. This calculator was able to multiply and divide. Someone recreated the Pascal line using Legos, and we'll tell you how the original Pascal line would have worked using this machine as an example. The idea is actually quite simple. You enter a number using dials, or in this case levers, at the front of the machine. After you are done with that, you can enter the number that you want to add and you can read the answer at the top. In this case, 5372 plus 6148 equals 11,520. You can continue with the same number as before, so 11,520 plus 9,510 would equal 21,030. You could also subtract the second number from the first by switching a lever right after you entered the first number.
Probably the most exciting mechanical calculator was the Curta, a very compact and good-looking machine. Here, Tested will tell you how it works.
So let's do a simple mathematical problem. Something that anyone could do. Multiplication. Sure. Let's do 342.
Okay, so you dial in one of your multipliers, so 342.
All right.
All right. And then by what?
Multiplied by, let's say, 257.
Okay, so basically what you do is you have this this up here, and this moves. And this is your ones, your tens, and your 100s. Okay. So what we're going to do is we're going to go to the ones position, and we're going to dial in the ones. So that what was the number again?
Let's say 257.
257. Okay. So up top here, this is your results dial, and this is your multiplier dial. Okay. So what we have here is we're going to go to the ones. So that would be 7. Okay. And we're going to crank it 7 times.
Oh, so on one side it's sliding, and the second number it's cranking. Okay, you've cranked.
Yeah.
All right.
So you can see here we have a 7.
All right.
In the ones
a 7.
position.
Okay.
All right.
And then now you pull that up and shift. Now you're cranked to your tens.
So
and say 5.
So we're going to do it 5. So let's see if I can make sure you see this. 1.
Now
2,
I'm going to cheat
3,
and pull out my
4, 5.
digital
So
calculator.
And then 2, so you got the 100. And we're getting to 1, 2. So at this point we have our other multiplier, 257. We have our 342. And if we did this correctly, we should have the correct answer, which I have 87,894.
Now onto the part you have all been waiting for, electronic calculators!
The first calculator worth mentioning is the ENIAC. The ENIAC was 1000 times faster than electromechanical computers that came before and could hold a 10-digit decimal number in memory. But to do so, this required 70,468 vacuum tubes, 2700 crystal diodes, 1500 relays, 17,000 resistors, 10,000 capacitors and around 5 million hand-soldered joints. It weighed about 27 tons, took up 1800 square feet of floor space and consumed as much power as a small town. Not exactly a desktop solution. The first practical solution was the ANITA, which stands for A New Inspiration to Accounting. It would set you back around 355 pounds or 7,400 euros in today's money. Surprisingly, a lot of people actually bought this overpriced piece of tech and 3 new competitors appeared. Those successors were transistor-based and even more expensive, about 18,500 euros. The strange fact is that none of these were actually superior to the ANITA in any way.
Finally, in 1967, Texas Instruments released the first handheld electronic device, a calculator able to add, subtract, multiply and divide while being compact enough to fit inside your hand. It printed the answers on a sheet of paper because they hated trees. Okay, they didn't have any screens back then. In the following years, calculators developed rapidly and the calculator wars had started. Sharp, Texas, HP, Canon and Casio soon dominated the battlefield in a bloody fight to the death with the release of new calculators every year. Canon and HP didn't stand a chance against the mad power of the Casio, Texas and Sharp, so they went back to making photo cameras and laptops. Meanwhile, Texas and Casio teamed up against Sharp and they still dominate the market up till now.
That'll conclude the history of calculators. Many actions and inventions led to the machines we so love to use all day long and without we'd all fail algebra hopelessly. There are exceptions to failing algebra hopelessly though. One of them is the human calculator, a man who has trained himself to solve mathematical problems as fast as possible. We've collected a few clips from him putting his math power to the test.
What else can you do? Well, let's try a little division. Just give me somebody with a 3-digit number and we'll divide it by a 1-digit number. Use odd numbers so we'll get decimals and stuff, all right?
Okay, no problem. 531.
531 divided by?
7.
That would be 75.8571428571442.
Check that out, man.
You have one more decimal point than us. You're correct.
To prove that point, we have a few equations for you.
What do you want to
You
try?
have not seen any of these equations beforehand, we should point out.
Okay.
Let's see if you can figure them out. We're going to ask you to add 4 3-digit numbers together.
Okay.
397
Plus,
723
plus,
599
plus,
184.
1903.
Oh, yes, it is. All right, here's a tougher question.
All right.
It's a long division question.
Okay.
I like being the one asking the questions,
Yeah, it's
by the
easy,
way.
isn't it?
923 divided by 7.
131.8571428.5.
Oh my gosh, we only had to point
Yeah,
to one
I'm sorry,
form.
I got
You
carried
actually
away,
did it
yeah.
more than we did. Okay. All right, last one.
All
I think
right.
you've proven your point, though. You can do equations backwards.
Yes, usually.
Okay. Usually. All right. I will multiply a number by itself 3 times and give you the answer. Then you tell me what number I started with.
Right, so just tell me the answer you got. Don't tell me
Okay.
the number you started with. Go
Here's
ahead.
the answer.
Yeah, and I'll do the cube root.
Okay, 912673.
97.
That was really fast, and you're
Yeah,
correct.
well, that's what I do.
Anybody like to? And some of you brought your own calculators.
I love
and you got
it.
Anybody like to challenge Scott? Or
Let's do cube roots. Do you guys know how to do cube roots? All right, let's try a cube root. All right, so everybody with a calculator, punch in. To get started, let's see. My brain's still loosening up here. Let's start with 2-digit numbers. So everybody, punch in a 2-digit number, a wacky number. Don't use 50 or 20 or anything like that. You got it? Punch it in. Now hit the times key, and then hit the same 2-digit number again, and then hit the times key, and hit the same 2-digit number again, and hit equals. And you just cubed a number. You should get some really big numbers on your calculator, right? So if you tell me the answer on your screen, I will extract the cube root out of that number. So who got a right answer? Okay, let's start with you.
97,336.
46. Yeah, all right, come on, tougher one. Who else? Yeah, back there, go ahead. 22? Yeah, that was easy. Wait, who else? Somebody else? 89.
By the way, he's right.
Part psychic, too. Go ahead. One more. Come on. Toughest one. Anybody else get one? Okay. Yeah, go ahead.
21,952.
Really? 28? Is that right? 28? Okay. All right, so now let's try birthdays.
Now we are really at the end of our presentation. We hoped you liked it and remembered at least a little bit. The end!